Alright, so today we are going to talk about what's new in wireless. Some of you already know all about wireless. There is a lot of things which have happened in the last few years. And so what's happening is what it is about. So we'll talk about the history, and then about the hype cycle, then what is happening from the industry point of view. First of all, everything that I'm going to talk in this lecture is as good as any astrologer can make it. Okay? So nobody really knows. Nobody had forecasted that this will happen in 2015, let's say before 2007, when iPhone came about. And the same thing, we don't know what next is, right? But this is a linear prediction from the industry. Linear means that whatever is happening, we just extend it and say, this same thing will happen in 5 years from now. And I'm guaranteeing you, somebody will come up with something that will change the whole direction. Okay? But we don't know that. So we can't talk about it. Nobody can talk about it. So we will just do this one. And so with wireless history, actually wireless is pretty old. 1880s, Hertz discovered that things can go without wire. Right? 1880. However, nothing really happened, and we can read line by line. Nothing really happened till almost 1997 in terms of computer communication. So Wi-Fi was standardized in 1997, and it was running at 2 megabits per second. 2 megabits. So some of you who use today Wi-Fi at 600 megabits would be surprised that we had it at 2 megabits. And that was the challenge at that time. We couldn't do any faster than that because we knew that 10 megabit is Ethernet, and Ethernet was making 100 megabit at that time, but we couldn't touch it. We couldn't touch that speed with wireless with any reasonable cost. It's like today, somebody said 5 gigabits, I would say, yeah, we can do it with wireless. Gigabit, right? If somebody said 5 terabits, I wouldn't touch it, right? So same thing, these higher speeds, they're untouchable. And so with 2 megabits, today you can see in 18 years later where we are. How fast things have changed. And this happens to all the technologies. All the technologies follow this S-shaped curve where in the beginning you have to do a lot of work and you make very little money. And that is when it is done by you, the students, very cheap, very good. Right? Research by us, professors, same thing. But as soon as there is a potential that all the key problems have been solved, and then what happens is with very little effort, you can make a lot of money. That's when the technology goes to the startups. Right? That's where people make millions and billions. And then it becomes to the peak of the hype. And at that point, people know that there are many things that cannot do. Before that, everything can be done with this new thing that we have. And I generally give an example of a marriage. Before marriage, the life is made up of dreams. There is this other person, who will solve all my problems ideally, and there are nothing else left, right? But after marriage, the life is different. So, with that, we come down, and we find out that it cannot solve all the problems. Some problems it can solve, but not all the problems. And so then basically the startups go away, and then the big companies come in. And after this, basically either the technology dies, or if it survives, then it is basically the matter of manufacturing it cheaply. Because there's not much innovation to be done, it just make it cheaper. Whoever can make it cheaper can sell it. Alright? And that's when the technology goes out of India, goes out of USA, countries where manufacturing is best, cheapest. You know that, right? So this is the thing. And so what it is that we really want to work on here, the professors, and maybe here. Alright? So we are teaching you how to work here, and then you get out of here, and then you start your own startup. And so you learn first thing is that you need to work on the left of this curve, not on the right. And here is the curve. I looked very hard for 2015. A question?
Oh, yeah, I was wondering, like, are Gartner the same people that do this hype cycle?
This is Gartner's hype cycle. This is Gartner's hype cycle. And talking of the Gartner, luckily for WashU people, Gartner is free. I discovered it last time. I don't know. Django is here? Oh, yeah, right. He told me. And so I really appreciate that. You can go to Gartner, do some search like Gartner at Wostel.edu or something like that, and you will find how to get there without paying, because these reports cost $5,000. And so I and you cannot afford it. So basically, with Gartner you can find, and I did try to search for latest one, but this is the latest one that I could find, so 2013. But basically what this graph shows is what is on the left and what is on the right. Okay, so right now, you don't want to do too much research in this area. This is where you want to be. LTE advanced, 5G, cognitive radio, 11AH, blah, blah, blah. This is where we will spend a lot of our time in this class as well. And this is where we want to spend, but you cannot really go to the left without going to the right in the class. I mean, because I need to teach you about the things which have happened in the past little bit. Okay? So one of the first things that we do every year in every class for everything and for my own research is to find out what is happening, what is going to happen, what industry thing is going to happen. At least we have to know about it, we have to teach about it. Okay? So with that, let's see. Here's the list. Actually, this is from the Gartner's list, from the previous graph that you saw. And I put it here, what these are. 5G. So 5G, there is a lot of activity on 5G. What is 5G? We don't know yet. Nobody knows it yet. But it is something beyond 4G. All of us have 4G. Right? Your phone says 4G. And so by 2020, there will be 5G. 2020 is 5 years away. By that time, we should have 5G. And so the ITU, etc. are working on it. And this will be 100 times the LTE. So right now you have LTE, and this will be 100 times. We are talking in gigabits on your cell phone. Okay? How is all this possible, right? So we'll talk about that. Cognitive radio. Cognitive radio is find unused channels and use them. So the problem is that there is no spectrum. So the government of different countries, including the United States, starting with the United States, let me put it this way, has given permission to use the unused channels. So if there is a TV channel which the TV station is not using, you can go ahead and use it. But the rule is within few seconds of their coming on, you have to get off. So how do you do that? Cognitive. AH. Now AH is about Internet of Things. And Internet of Things is basically everything is going to have internet connection. And so everything in your house will be internet connected. And so what we need is a technology that is standard, cheap, and goes long distance. And so Wi-Fi guys decided to do this AH, which is in response to Zigbee and Bluetooth trying to get there. Okay, so this is the version of Wi-Fi which goes very long distance, doesn't need very much speed, so it is only runs at only few kilobits per second, but it goes very long distance. So your little thing somewhere, very cheaply can talk long distance. Then terahertz waves. So when we talk about this spectrum in the next class, actually, so this is also called sub-millimeter waves. Every frequency, every wave is measured by the wavelength and by the frequency. So the wavelength is sub-millimeter, less than a millimeter. and the frequency is many terahertz. If you increase the frequency too high, it becomes light. If you decrease the frequency too low, it becomes sound. Okay, so right now I have wireless transmission, except it is not radio. Like radio is in between the sound and the light. Right? So terahertz is very high up there. And as you go up in the frequency, and this is all next week's lecture, you will see the things start behaving like light. As you go down in the speed, it behaves like a sound. The radio behaves like a sound. So at very high frequencies like this, it goes in a straight line and cannot go through that door. Okay? And so we will study all this next time. But for now, terahertz waves are coming up. 0.3 to 3 terahertz between radio and light. 802.11 AD. That's another attempt by 802.11 guys. And 802.11 is done at IEEE. And all of you can go to IEEE. IEEE is open forum. Any of you, if you decide to go to IEEE, you just have to look up in IEEE when there is next meeting. You go there. Except that right now they charge you $800 registration fee for each meeting. If you pay that, you are in. You can go to any meeting. You can discuss, talk. You cannot vote until you go 3 times. So I go there once a year, and just to figure out what's going on. Okay? So there are all kinds of people in 802. 802.11 AH guys are the one that want to have low speed but long distance. AD guys are the other corner of the room. They want to go short distance but at a very high speed. Yeah.
You say long distance, what's the...
Yeah, that's a relative term. Longer than the other Wi-Fi's. Right? Because this is Wi-Fi. And the advantage of Wi-Fi is that these devices can somehow speak 802.11. So if your laptop is 802.11, it can somehow talk to this. Okay? As opposed to LTE. If your laptop has Wi-Fi and you have a long distance LTE, you can't talk. Right? You cannot talk, right? So this is Wi-Fi, but the version of Wi-Fi which goes very short distance, but many gigabits. AD, yeah.
Is it shorter than the one we have right now, or the same?
It's shorter than what we have right now. Right now, the thing is, your Wi-Fi can go all over the room. All over the house. Right? This one will not go all over the house. This will go maybe from here to this wall, maybe. But why do you need it? You need it because you want to connect your TV. You want to connect your TV to a VCR. You want to do some things which is very high speed, but very short distance.
So it replaces the cable, the Ethernet cable?
Yeah, it just replaces the cable. See, right now if you go behind your TV, there's a big mess in every room, in everybody's house. Okay, because you have 15 devices trying to connect to the TV, 15 cables and 15 power cables. There's no way to organize them. AD will get rid of all of that except the power cable. Right? 15 power cables still. So that is AD. Smart antennas. So the thing is, antennas have all kinds of things, like they need a direction, they need an orientation. If you put the antenna this way, you get different signal. If you put it this way, there is different signal. So can't we make them smart so that they do it themselves rather than you're going and tuning them up? Actually in our old house, we don't no longer use antenna. But in our old house, we had a rotor which will rotate the antenna into the right direction. TV antenna. Now we don't use TV antennas anymore because we get everything through the cable. Right? So many of you have not seen those antennas, but many of you might have seen outside some houses which are still there, right? Those big, Yagi and things like that, antenna. Okay, so smart antennas. LTE advanced. LTE is already here. But there is LTE advanced, which is next generation of LTE, which may not be 100 times, but maybe 10 times, so that is in between. 802.11 AC. No, yeah, go ahead.
What do you mean by real 4G on LTE advanced?
Okay, so what happened was, this is a story, thank you for asking. We were working on WiMAX. And you can see on my website hundreds of contributions to WiMAX. We also got, WiMAX individual contribution award, contributor award, and all that. And that was supposed to be 4G. Okay, WiMAX. And then what happened is suddenly people, actually that was on the way to 4G. Actually, it was not 4G. It was 3.75G or something like that. Anyway, so people, there was this industry tension between the carriers and the data people. There are two kinds of networking guys. One who work for the phone company, one who work for the other companies like, enterprise, like, Facebook or Google or something. They are not phone companies. So WiMAX was popular with the enterprise, and other guys will not have anything, but they just took most of the things from WiMAX and called it LTE and immediately called it 4G. So this was not supposed to be 4G. And so there was a plan for 4G from ITU, and which they had invited them, as to how will you do this, and WiMAX had presented a proposal called WiMAX version 2 or something, and LTE had presented a proposal, but both of them were served and people started making LTE, and now you have LTE, and then they had a problem what to call it. 3.75G doesn't sell, so they call it 4G. So there is this now there is LTE Advanced, and I would not be surprised if LTE Advanced is called 5G, and then real 5G will be called 6G. So that has to happen. That hasn't happened yet. But marketing people are ahead of the technology people. Right now, 5G is still being designed. But by the time 2020, nobody is going to wait. And I would not be surprised if, by before that, this LTE Advanced comes in as 5G. This is the real 4G. Yeah.
So it's not clear for me. Sometimes the network appears as 4G, sometimes a bit like LTE. So they are the same.
Actually, they are the same, because there's nothing other than LTE right now. Okay, so whether it is LTE or 4G, it's the same thing. So the thing is, now I got to check, now that you asked, I got to check whether, are there any LTE advanced equipment already in?
I think in South Korea, Samsung, they have devices, they have LTE advanced in there.
They have advanced in there?
Yeah.
So maybe. So I got to check this out. I won't make any statement until I check this out. But LTE Advanced is 4G, and maybe if they are showing you LTE and 4G, then they are being somewhat truthful. Okay, how far we are? AC. AC is the highest speed Wi-Fi, normal distance Wi-Fi available right now. If you buy anything today, you generally buy AC. It goes several hundred megabits per second and goes quite a bit of distance, covers the whole house. Okay, so AC is the high speed Wi-Fi. Wi-Fi direct is another thing which is happening, and Wi-Fi direct is basically that sometimes we really don't want to talk in every direction. We want to talk in a particular direction. So why not just connect to one station rather than connecting to 15 people? And so that way you can save some energy and you can get longer distances, higher speed with point to point. And you don't need the access point. Yeah.
Is that the one? It's supposed to be AC, the Wi-Fi direct?
No, they're not the same, but Wi-Fi direct is a mode in AC. So if you have AC, you might have a feature which says we do Wi-Fi direct. In that case, it will just talk to somebody else. So Wi-Fi direct actually is not really a special thing. It's just a feature which can be added. $11U is in increasing security. Previously we had 11I, which was very secure, and before that I think we had 11E, and so 11U is authentication for hotspots, and that is still very kind of a problematic. Right now when you go to any hotel, you never know, there is no standard way to connect to Wi-Fi. Some hotels will you connect to something and you're trying to do Google, you have to do Google, and then suddenly the hotel website will come up, and then your browser will complain that this is not the right website, you are being attacked, this and that, and you say, no, go ahead, and then they'll get you a point where you can put a password. Is that the right way to do authentication? No. There should be some way so that, it's a standard, so you just connect it, right? That is what 11U is all about. But anyway, small cells. Small cells, basically, the current cells are few kilometers. They put it high on the tower. And the longer the distance, the less speed you get. If you want to get higher speed, we have to put many towers, very, very close. So that makes the cell smaller. Right? They could be as small as this room size. So basically, there are picocells, femtocells, all kinds of cells. And you can put a cell in my home. I do have a femtocell or picocell. Basically, what happens is because I cannot get the signal, the carrier signal directly from their big tower, they have asked me to put one of their devices on the window so it gets some signal from the tower, and then it broadcasts inside, so I still get some signal on my cell phone. Okay? Yeah.
I heard about the internet one.
SNS?
The internet signal that's using the internet cable.
Oh yeah, so then that's a different one. This is small cell is still not coming through wire. So there is another way that he's pointing out is that in this case, you really don't have to come through the wireless. You could come through your cable like U-verse or something, and then you could transmit it in your room. That's a different technology, and that is probably not on this list, but could be. Okay, here in the small cells, it comes. And by the way, I have T-Mobile, and this was the problem basically. Actually, this was the problem with AT&T as well in my home because it was kind of out in the suburb, and the signal from every carrier is very weak. And T-Mobile provided me with this free thing, and so I'm happy with that. 802.22. Now this is an attempt to cover the longer distances. This is not 11, but this is still 802, and I will describe to you later on as to what it means to be 802 and what it means to be 11. I already described what it means to be 11. 11 means that you have to talk to other 11s. 22 does not have to talk to other 11s. But they still have to follow all the 802 rules which are there. And we will talk about those too. So this is a regional area. Regional means a city. So with 802.22, you can talk all over the city. It's like WiMAX and LTE. But it is from IEEE. WiMAX was from WiMAX Forum. LTE is from ITU or HC and things like that. So there are different standards bodies that compete for the same problem. Okay, and just thinking loud, and I haven't done checking on this. I think 22 is not going to succeed given that LTE is already here. So it might be history. Super Wi-Fi. Yeah.
What is white spaces?
White spaces. Yeah. Good. Thank you for asking. So cognitive radio is also called white spaces. And I already described cognitive radio is when that you use the television channels when the television channel is not active. Right? So that is called white space because space has been allocated but there is no residents there right now. Okay? And so if you have, and we will discuss that in this class, if you have this white space device, then basically you scan all the channels continuously. Alright, and you stay on one channel. When you see somebody's come on this one, you go to the next channel that you have available. And then you come back to the first channel. So the user doesn't see any of this. The device does this automatically. White spaces. Super Wi-Fi is another version of 802.22, but this is Wi-Fi using TV white spaces. So you see, even in 82, there are two different standards trying to solve the same problem. And LTD, LTE. So China didn't want to use LTE, so they have their own version of LTE called TD-LTE, time division duplexing rather than frequency division duplexing. So it uses TD-LTE. And there is a history behind it because they have been using time division in the previous versions of wireless, and they're a big market by themselves. Very large part of the world is they cover, right? So they can have their own standards. So they have TD-LTE. Zigbee. And Zigbee you have heard about. This is for IoT, Internet of Things. Zigbee is the standard being done by something Zigbee Association or whatever for connecting Internet of Things. Again, they are getting a lot of competition from IEEE and from Bluetooth. Yeah.
Sorry, I would like to ask.
No, they're not to be sorry. This is good. I mean, I encourage questions. Go ahead. Yeah.
I'd like to ask about the TD-LTE.
Yeah.
Is it the same speed as the frequency?
Same speed and frequency as LTE?
Yeah.
Yeah.
But even with the lot of users? Maybe.
Okay, so when we go to LTE, we will talk about time division and frequency division. What's the difference? Why you need time division? So there are two versions of LTE actually, just to be correct about it. And there are some advantages of time division.
Because we have two of these.
Huh?
My home country, we use both of them.
You use both of them? You have TD-LTE?
Yes, and this is TD-LTE.
Okay.
The Wi-Fi version.
Yeah, so somebody has to... See, the thing is, I mean, you can have one device which can do all of these, right? But all you're doing is you're putting 5 chips there. You see? So the standards may not be compatible all the way through, but some parts may be same and some parts may be different, right? So you can optimize that. Good. Thank you for asking that. Right now, I haven't explained you time division, which is kind of you probably know, but when we come to these things, we will describe in more detail. Actually, I think all of these topics are covered in this course. So, hopefully. 802.11r. So, I was wrong about China. See, the thing is, there is some politics in the standards bodies, and there is some patenting rights, this and that, which I don't want to go right now. But many countries don't like the idea that some other countries just take the money for the technology. I would complain, right? I mean, so you would complain, but so that's what it is. So they don't want to use this other standards; they want to have their own standards. And then, of course, that can be sold to other countries. But the thing is that I'm surprised that they are using in your country. But basically, I thought that it was for internal use in China. So far, I thought that.
But the module is from China.
Eh?
The modules they are using is from China.
Everything is from China, right? So the thing is, here the thing about China is that China has to manufacture LTE anyway, because how can they sell in America, right? So all the equipment comes from China. However, for internal use, they did not want to pay the royalties, and that's a big population and big thing like that. And there are lots of politics about that. So they were different, and the same thing goes on. Actually, I can tell you a story, just a story. So Europe is different than USA in most of the communication technologies as we go through this, for similar reasons and some other reasons. Okay, so your television here does not work in Europe. Phone luckily works nowadays, but previously it did not. Okay, and even wired phone will not work. So there's a reason for it. Electricity is different. And why is it different? I can go through that history later on. Alright, so 802.11r. So basically, nowadays people are very, very mobile. And we go from station to station to station. When you go from here to my office, you've probably gone through several base stations. And if everywhere you have to authenticate yourself, your connection will be brought down. And so they have come up with fast method where you are pre-authenticated somehow, and you just go and your connection continues. LTE is long-term evolution 3.9G. Okay, you already know all that. All right. Now everything in the world is following Moore's law. Everybody knows Moore's law? Right? So, which means that it doubles every 18 months. Okay? And the reason it doubles is because of the hardware. The Intel and everybody else, and this Moore is the Intel's president or ex-president. And so he observed from his own company's progress that every 18 months they double the speed. So he said that, basically he said that several years ago, that every 18 months we double the speed, and that has become a law. Okay? And they have followed it. So every 18 months, by straight line, you can see hardware, software, all the technologies are following that. Right? So the wireless, if you want to go do nothing else, it will become faster simply because the hardware is faster. Computer will become faster because hardware is faster. And then we will come up with some new things that will make it even faster. Alright, now I am coming to what is happening in the mobile world. Now all this is brand new. Every year I have to do this one. In particular, Cisco comes up with a forecast. They are in the business of networking. So they come up with a forecast for the next 5 years. So in 2014, they did this 2019, and I was surprised that they don't have a 2015 one. And we are in 2016 already. So 2014 to 19 is the latest one. That's why I redlined this. So everything when I say next 5 years, that meant next 4 years or 3 years, something like that, because this is 2014. Okay? So, you don't have to remember, for the example, with all the percentages and things like that, but what I'm trying to say here is, and I have tried to minimize the percentages, is that just to know the trends, where the world is going. Okay? If it is going up and you think it is going down, then we are in trouble. Right? So, remember that part. Right? So, IP traffic, they measured it, and actually this is the summary of all the other forecasts that they could find in the industry. So they subscribe to Gartner, they subscribe to other people, and they put it together, some of their own measurements with this report. So this is kind of, I should use the word Bible, for the rest of the industry to follow for that year. So the companies have to decide how much money to spend where and what to do, what products and all that. So we look at these kind of trends. So global IP traffic, it increased 5x in the last 5 years, and it will increase 3x in the next 5 years, according to them. Now, again, next nobody has seen, but this is their forecast because it is going too fast, and they think that it will somehow slow down. I would not be surprised if it becomes 5x, or maybe it becomes 7x, who knows. Right? So, another way of saying this 3x is 23% compound annual growth rate. So if you do 1.23 raised to 5, can somebody do 1.23 raised to 5 and see how much number comes out? I think that should come out to 3 or 5, one of the two numbers. 1.23, 23% every year, right? So 1.23 raised to 5. Times 5 is already 6. Come on. 3.15? 1.23 raised to 5 is? 2.815. Okay, 2.8. So 3x. Basically 23% is the correct number, 3x is approximate. Alright? However, now this traffic is not the same for all the time, for all the places, for all the kinds of things, right? So now we are going to break it down into pieces. So first of all, by time, busy hour traffic is different than other hours traffic, right? So when we design a network, when we put a network, we don't put it for the average traffic. If you put the network, if you design the network, if you design your building for average traffic, you would be really unhappy, right? But you cannot design for the worst case either. So what we do is we try to design it for a busy hour kind of thing, so that we are not really the worst case, but we are somewhere where we can afford it too. So busy hour traffic is going to grow by 3.4x in the next 5 years. So instead of 3 to 3.4, yeah.
So what time of day does that refer to?
Yeah. So busy hour actually is coming up in the next slide. So what I have is 12 key points from that report. And by the way, I would like you, all of you, to download that report and read it in full. Okay? And so you will find the same information there. But I have taken some key points and put it in the first slide. And then I have one slide on each of these. So I will show you the same thing graphically. So what time of the day that is? That is basically the prime time when most of the people will watch video. So what is the prime time for TV? Anybody knows?
After working hours.
Yeah, after 5 o'clock, between 5 and 8. So somewhere there is a busy hour. Prime time. Okay? Mobile data traffic will increase. Now there is a mobile and station. So this IP traffic, right? IP includes both wired and wireless. So now we will go into mobile. That will increase 10x. So your phone traffic is going to go up much faster than the wired traffic. Connections don't even work here anymore. So the thing is 10x. So if you really want to, if you are at a networking company and you want to put your money, would you put it on the wired networks or put it on the wireless networks? Right? That's the kind of questions people are asking. Business and home. Business traffic will go only by 2x, so it is less increase. Now let me just say one more thing. This is not the whole story, because sometimes this access can fool you, because when you say 2x, it's the rate at which they are growing, but you don't know how much money there is. Right? Because there could be 2x of 100,000 is different than 5x of 1,000. Right? So these are all marketing numbers. And so, but business traffic is not growing because they're not watching TV. They're not doing anything that people are doing. All right? So there are different markets. There are different, this one, and the business is less. Metro and long haul. Now we go into the distance. Okay? So metro is a city, long haul is intercity. Metro is 2/3 and long haul is 1/3. So of the whole IP traffic, 2/3 is going into the same city, 1/3 is going out of the city. So it's like local call versus long distance calls, or local internet versus long distance internet, whatever you want to call it. So there is most of the traffic stays local. And how does that change anything? Well, if things are going to stay local, then it is better to have a local cache of everything, because you don't want to really have every web page come from, San Francisco. You might as well have a copy here, because that will save you a lot. Right? So metro traffic and long haul traffic. Metro traffic will go faster than long haul traffic. It is already high and will grow traffic. And it is because of the CDNs. What is a CDN? Content Distribution Network. So basically, when we realize that most of if you go to the original website for everything, it will take quite a bit of time. So they made copies of the website and put it everywhere. So today, if you are a Bank of America, or if you are, a small company, or even Washington, I'm sure, you don't put your website in one place. You give it to a CDN. You call what is the name of the company? CDN company. Anyway, you call them and you give them your page, and they will put it into 1,000 places. Your customers will be very happy. Okay? So that is called Content Distribution Network, basically local caches in every place. And because of that, the traffic has become local. Most of it doesn't go out. Even if you are going to China, you just get the result right here. Right? Because there is a copy right here. CDNs will carry a higher fraction of total traffic. And now CDNs are going to be even more. So they have 63% in 2019 versus 39% in 2014. So more and more CDNs will happen, and that has some effect that we'll talk about too. I mean, even our own research, we are designing networks that will take advantage of this fact, that we want to be local. Over half of IP traffic will originate from non-PC devices. So another thing to know is the PCs are going away. Desktops are already gone. Now, I have been in the computer business for 40 years. When I was studying, like you, basically when I did my master's, I worked on, what we call IBM 360s, which was like this whole building was one computer, this big. Okay, and we used to submit a job on the cards, punched cards, come back 2 days later and get the results. That was my master's. When I did my PhD at Harvard, it was a computer as big as this room, DEC 10. Okay, and a luxury here was a luxury that I could basically, there were lots of computers at Harvard, but they were not like this, they were like this room. Okay, and so that was what we called the mainframe era. And then by the time I was working for a mini computer company, digital equipment, and all the mainframe companies like CDC and whatever name you had, they went away. Mini computer. And then came the personal computer, and then the digital went away. And I became a professor. Okay? So the idea is you have to watch out for these things, and you have to move before they do. I did move before they did, by the way. So before they went out of business, all my friends were sold off to other companies, and I was already out. But you have to keep track of what's happening in the industry and be there. If your bosses don't want to be there, you have to be there. Right? So the digital went away because they were in the mini computer business and they never got to the PC business. PCs came in. Now the PCs are going away, and what is coming in? What is coming in? Mobile. Yeah, so okay, you can say tablets and this one and mobile. So you're not using. So the thing is, when PCs came in, they came in as a desktop. They went away. Now we have laptops. I don't know how many of you have a desktop. Okay, so soon you will get rid of it because after this you're not going to buy another one, are you? The thing is, because what does it give you except non-mobility? Yeah.
But I mean, when you say the PC has a more powerful thing than laptops or tablets.
Yeah, right. So the thing is, now they have become mobile because we are mobile. We just use this one. I remember my first lecture using recording, this recording, what we are doing today. Every lecture is being recorded. I did that in 1995 with 3 desktops, this much room here, right here. My TAs were sitting here, recording everything, right? 3 desktops. Can you imagine that now? Now you don't even see anything. So the life is changing. And now, I would not be surprised if I could just be putting this here and then recording everything. And I can do that actually, but I'm just not doing it. So the laptops are going to go away. Actually, they are saying that laptops will go away and tablets will come in. However, right at this minute, they are seeing resistance. Like people like me. Yeah.
The thing is, like cloud computing thing is going to be the future.
What computing?
Like cloud computing.
Right. The thing is, so the cloud computing is a totally different topic. And we will talk about that too later on. So when you say is the future, it's the current future. Everything in this slide is current future. So until we come up with something different, right, we cannot see anything beyond. Right? So yes, with that answer, yes. You have a question? Hello?
I was just wondering, over here I can't see anything about stuff like wearables. I know Google Glass got strapped, but I also
Yeah.
in the near future most of these things are here.
So that is on the top of the hype. So basically, I have a slide on that too, but basically, yeah. So Internet of Things is right now this year at the top of the hype and it's going to the other side. With that curve we saw, that is on the peak. If you were here last year or 2 years ago, if you wanted to start a startup, you would say, I am doing wearables, I am doing IoT, and then you will get a lot of money. Now it is top of the hype, and you might get some money this year, but as it is going to the other side, it will become only Google's thing or some big company's thing. Okay, right now, Samsung and Apple maybe, something like that, Right? So yes. Okay, where I was? I was in the half of the traffic will originate from non-PC devices. So the PCs are going away. All right. 8. Traffic from wireless devices will exceed those from wired. So wired is going away. Even if there is a wire that doesn't even work, that's the situation, nobody complains. Right? Number of devices will be 3 times the population size. Now, we had never thought about it before. Now, if you had asked me, 5 years ago, 6 years ago, before 2007, we would say, well, 7 billion is the population or 6 billion is the population, that is the number of people that will have the internet. But now everybody has 3 things going on. I have a watch, I have this, I have that. So the population size right now will be 3 times the population size. Devices on the internet. That includes your fridge and everything else, right? So video traffic will be 80% of consumer traffic. So the consumers are consuming mostly video. Businesses are not, right? So nowadays we don't think about anything about watching a TV, a movie on the internet, on the laptop, on the mobile, or even on the TV in my home. So the thing is, everything is basically, coming on the internet. And so video traffic will be 80% of consumer traffic. Millions of minutes of video will cross internet per second. In 1 second, how much video goes? Million minute. That is an interesting thing. Million minutes of video goes in 1 second. So much video. IP traffic's fastest growth rate is in the Middle East and Africa. Growth rate, and I redlined rate because again, otherwise you might think, oh, there is a lot of traffic in Middle East and Africa. There is not much traffic, but it is so small, it's going like this. You see what I mean? Is that, so many places wherever I said 3x or 4x or 5x, the story is only half a story because you have to look at what is in x of. Right? And so the next 12 slides are the same thing. I'm going to say it again so that it gets into your brain forever. IP traffic. So this is the actual number. Not that it gives you any more result than what I told you, and not that I want you to remember that it will be 168 whatever exabytes per month. But the idea is that it is going. And it is somewhat faster than the linear, but in my view, this is under prediction. Personal view. In my personal view, all the predictions are under prediction because nobody has seen the change. Okay? Everybody says the life will remain the same as it is today, and they predict. But the life is changing. And it doesn't go like this. I mean, very few things go like this, but most of the things are going like that. Okay? And so right now, this is the number as far as the Cisco can see. And this is where the 3x in 5 years comes from. We look at 59.9 to 168, that is 3x. Number of devices. So basically, one of the things that is common to all these graphs that you will see, the bar charts like this, the highest frequency thing is in the bottom. So the blue thing is the bottom, and let's try to see which is on the top. Top is other, so this is M to M. So machine to machine will be most of it. Number of devices, in terms of number of devices. So what is machine to machine? Basically, right now, generally there is a human being at the one end of most of the connections, internet connections. But in the future, human being will not be there. Your watch is talking to your phone is talking to your fridge is talking to your power supplier, grocery store, who knows. So this is basically machine to machine traffic. Right? And that's how it is 3x the population size, because population is not talking, it's the machines which are talking. Right? Then we go to the non-smart. The next thing is smartphones will be doing. Now this is a number only, right? So this is not the traffic. Just the number of M2M connections, number of smartphone connections, number of non-smartphone connections, number of TV connections, number of PC connections, tablet and others. So actually this is interesting that the tablets are only 3%. Now these two numbers, by the way, are 2014 and 2019. So they were 3% in 2014 and only 4% in 2019. I think it's very, very low, under prediction. But I don't have any better data. So, and I can argue, I can disagree, but can't present you a better number. Right? So, according to them, this is the future. Total traffic. Now, the thing is, we worry about the, so there are sometimes we switch to numbers, sometimes we switch to connections. Now we are talking about the bytes. Again, most of the bytes will be coming from PCs though. Let's see. Yeah, PCs is at the bottom and the other is at the top. You see, while PCs are going down in the numbers, but they produce a lot more than the smartphones even. Okay? And so you see, in 2014, they did, and the smartphones did so little, but it is growing very fast. So the growth rate is faster. The PCs are not growing very fast. They're almost constant, but they're big. Yeah.
Why there is fastest growth rate in Middle East and Africa?
Oh, because actually this will come up more later on. As I said already, is that I think somebody must have heard it. Why is it fastest growth in Middle East and Africa? Tell me. Did you hear something I said? Because their numbers are small. See, the thing is, if you are here and the world is here, you have to grow fast. Right? If you are here and the world is here, you cannot go very fast. Did you get that? Yeah.
Okay.
So the rates in the countries where Africa, for example, I mean, I wouldn't go to Middle East. Africa, for example, you can see the things are over here, right? And they have to grow fast to really catch up. Do you agree? Okay, that's the reason. All right. I mean, actually here itself, I mean, let's not go to countries. The PCs are very high and the laptops, smartphones are very slow. So they will really grow fast, although they will still be less than the PC. The small things can grow faster. So the thing is, marketing people will make a deal about things whichever they can make a big number, right? So if the traffic is less, they will say the rate is high. Okay? If the traffic is more, then obviously they will say, if you are a PC seller, what will you say from this graph? Oh, PC will keep the last traffic. And here it is, they will do so many exabytes and the mobile will do only so many exabytes. And they will win, right? And if you are selling smartphones, then you don't talk about the absolute numbers, you talk about the rates. So rates can be lying, right? And they would not even say 3x, they will say 300%. Because that 300 sounds very good. I'm saying 3x. And so some of these are marketing slides. All right, I think this is clear now, right? Yeah.
I'd like to ask, what do you mean the machine-to-machine thing?
Yeah.
Does it include the sensor thing to machine?
Yeah, that includes sensor to machine. Actually, most of it is actually in the industry. Machine to machine, most of the industries today already are interneted. They are already connected. You don't have people standing at every machine doing everything. Basically, machines do themselves and they tell every machine what to do. So that is called industrial internet, and that is machine to machine. It's not really at the home right now. Did I finish this? Oh, right. Video on demand. Now we come to the video. And what is happening in the video is that you see I have shown three things here: standard def, high def, and ultra high def. So 4K is coming in. Ultra high def is 4K. If you go to buy a TV today in Walmart or any other place, 4K is what they're selling, or 4K is what people are buying. And HD TV was last year. That is old story now. Ultra high HD is now the thing. So they're showing that standard is going down, standard TV. HD is going up, and 4K is coming up. Obviously, the 4K X would be very high, but the quantity would be less. IPv6. So, a question people keep asking in the United States in particular, when is IPv6 coming? So, this one is basically showing that according to Cisco, it will go 3 times in 5 years. 2 billion to 6 billion, 3 times. 1 billion, 3.7 billion. These are the fixed devices and mobile devices. Both ways, 3 times more, yeah.
Are there any countries where IPv6 is standard right now?
Okay, so IPv6 is standard worldwide. First of all, the question of the standard was done in 1991. Okay, so it is standard worldwide. However, one of the things in networking is that whatever exists, people just don't throw it away. So nobody is throwing away IPv4. All right, and because of that, the other thing is not coming in. And my laptops, both of these have both IPv4 and IPv6. Okay, the laptop that you're using, I can bet that they have IPv6. So it's all there, but you're not using it because the other people are not using it. You don't find a website which says, sorry, I don't take IPv4 traffic. All right. And so there is no IPv6 only website. There is no need for me to switch to IPv6. Right? So I continue to use IPv4 and I don't even enable IPv6. I think it is probably enabled here. But there is no reason for me to really use it much, right? So that's the problem. But in some countries, and again I can go back to Asian countries, there is not enough IP addresses. IPv4 addresses. In the USA, we are lucky because we were here first. So we kept all the IP addresses for ourselves. So every student has an IP address. I mean, my computer, they have public IP addresses, both of these right now, right this minute. You cannot have this luxury in anywhere else in the world. Okay, one university will have one IP address, IPv4 address. So they got to use IPv6. So it will come there much faster. Okay?
Are those global or just for the US?
So this is global. Because if it was US, the number would be low. Now the countries, more story about the country. So you see the bottom is blue, which is Asia Pacific. Okay, so Asia Pacific is very low, but it's going to grow up very fast to become 33.7%. And America, right here, North America, which is US and Canada and Mexico, they will become 27% and so on and so forth. So the Asia Pacific has the highest growth rate. Middle East is 106%. So Middle East is, okay, so here's the thing now. Now you see, Middle East is growing highest. You cannot even see from this graph though, because the numbers are so small. 6.5% out of, something like 1/10 of that. So that's why I'm showing both types of graphs here. So by looking at this graph, you know that you're not just going to go and start in our business in Middle East. Because if you have, the thing is growing very fast, but the amount is small. In US, so basically right now actually for companies, from companies' point of view, Asia Pacific is hot. Because the amount is large and the growth rate is not bad, 33%. Okay? IoT, Internet of Things, and you will hear about this a lot. So this is the number of M2M connections, billions of M2M connections, 2 billion, 4 billion, 6 billion, 8 billion, 10 billion, 12 billion, M2M. We are talking about M2M. And most of it is going to be in home. Actually, according to this, right now it is home. And manufacturing is green, which I can't even see anywhere. So I was saying that most of this M2M is in the industry. That is not true according to Cisco. And so I may correct that, but I kind of would disagree with these kinds of numbers. My home doesn't have it. So I don't know which home has it. Okay, these are the M2M connections. According to them, we should have about 2.5 billion connections right now in the United States. This is what? Connected home. Well, this is worldwide, so but I don't see anywhere else either. I mean, if they're not in the United States, where are they? Yeah.
Why do you think the growth is so much more in the home than in enterprise setting? Because the enterprise seems like it'd be able to adapt faster, or at least have a higher.
Right. So here thing. Okay. You have to distinguish between the numbers and the total. And I give this lecture when I go to India. In India, everything is large in numbers. It is 3 times US population. 300 billion. How many? 200 billion here? Over there? How many? How many billion people in America? US?
300 million.
Okay, all right. So 3 times, the population is 3 times. So everything is large in numbers in India. But when you combine the total, it's very small. So you say the income, you take the TVs, you take anything, cars, large in numbers, but the total is small because that is the design. Right? So I was going to bring it to the industry versus homes. There are a lot many more homes than industries. In this city, how many homes are there and how many companies are there? Right? So when you count, and this is a count, the homes will win, but when we see the traffic, it may be a different story. However, we just noticed that is not a different story because they don't watch video. So, so that explains that part.
But it doesn't necessarily mean that the home will be more profitable.
Well, actually, that is what the industry is believing right now. So let me tell you what is happening in the industry. In the industry, everybody is betting on the home except for GE. GE is going after the industry. So GE calls it industrial, something, I forget the name. So GE is betting there and everybody else is betting here. And the reason they are betting here is because Google invested $2 billion to buy a company that was making a thermostat. Nest. Right? That just woke up everybody. $2 billion for a thermostat. I mean, there is the Honeywell, they make all kinds of thermostat, man. Nobody buys them for $2 billion. Right? So, these are all, I mean, okay, so I don't know. I mean, like, I don't know about the future part, but this is basically where the current thinking is. And right now things are very cheap. I just bought a $3. For $3, I bought a Wi-Fi switch. So basically, I can turn on the basement light by my iPhone. And the thing costs $3. I don't need it, but why not? And so things are coming down, everybody is competing, and then the prices will be really depressed soon. I mean, because I don't know how they make money in that $3. You know, I mean, after all, it is an electrical switch, which costs $3 anyway. Huh?
Mass protection.
Well, I think they're just trying to get people used to it. Or, sometimes there are lots of reasons as to why things are at that price, that they want me to come to the store, which I then never went. Things like that. Anyway, so applications. So now we talk about applications, where all the traffic is going. So again, you see the bottom line right here, blue is internet video. And how does it affect your research? Why do you need to know in the university? Because if you don't do research which really addresses that problem of the video, the real time, the streaming, you are working on the wrong problem. There are a lot of people who are writing paper how to fix Ethernet, contention control. Come on now, CSM and CD. Nobody is using it. They don't even know that it is gone out of the world. They're still working on some old problem because it is mathematical. So if you want to apply mathematics, apply to things that people are using, or people will be using. And that's why we study this. That if video is going to be there, the timing is key. What kind of video is it going to be? Is it the video which is stored? If it is stored, then the caching is the solution. If it is not, if it is a real-time video, like, doing FaceTime, that cannot be stored on the CDN. How do you do that? Right? So these are the things that we need to know as to where the world is going so that we can decide where we want to go. Okay, let me see. 80% of traffic is video. There is another problem with the video. Video is highly asymmetric. Because when you are watching TV, you are not sending anything to Amazon, maybe a few bits. Most of it is coming this way. Right? And asymmetric is a problem because now you need a 10 gigabit link on which one lane is empty. The reverse lane, nothing is going on. So what do you do? I mean, either you design networks that are asymmetric or you do something, right? So that's the issue. So people are thinking about P2P distribution, which could make it symmetric. So when I am watching TV, you are watching TV, your neighbor is watching TV, Amazon only sends you one stream to your neighbor and you get it from your neighbor. So now your neighbor is uploading. So the bit becomes symmetric. And believe it or not, many things are P2P. I was just downloading something and I forget where it was, from Microsoft or Apple or something. And then it gave me an option of getting it basically by a P2P, which means somebody else's home will give it to me. And then it asked me whether I will participate in that one to give it to somebody else. And I said, forget it right now. So P2P is coming in for that reason. Because the traffic is so asymmetric that it is not worth sending gigabit from the original source.